recording and I'm going to share my screen. All right. So good morning, friends. So welcome back to another session on Java Babies, covering Java basics. So today we will switch gears and talk about Java threads. In fact, before even said, I think we should talk about uh, in real life, how do we do our day-to-day stuff. So I want to talk about preparing breakfast. In fact, yeah. So please give me some inputs. So preparing breakfast, what are the steps you follow?
I think you boil water.
Boil water. Okay, boil
Mm.
water will take some time, yeah. So maybe I'll probably so maybe let's say one cell represents 1 minute, yeah. So and let me create a timeline there. So time 0 minutes, 1, 2. Yeah. So how much time does boiling water take usually?
Maybe 3 minutes to 5 minutes.
Okay. And while water is boiling, do you do something else at all?
Yeah, maybe depends on what you make, but like yeah, we can maybe fry eggs or
Okay, so I'll probably write it down like this. Task one is to boil water, yeah, and then task two is to fry egg.
yeah, and also to get the milk out.
I'm guessing you're making a tea. Milk tea.
Yeah,
Task three is to get milk. Get milk. Let's call it get milk. Rakesh, any input you want to give, or you never usually make breakfast?
Mm, okay, breakfast, right? So while boiling water itself, you will take out the milk
Okay,
normally.
correct. And you fry eggs. Maybe that also takes a few minutes. What do you say?
Yes.
Okay. Okay, cool. How about another task that you might be doing, Rakesh?
Mm. Uh,
Maybe
this,
toast the bread or something? What is it?
yeah, toast the bread,
So
set
maybe
up the
once,
breakfast table, task 5 by that time.
yeah, correct. In fact, I'll just add make tea. Huh? Make tea. We
Mm.
forgot the tea because we were boiling water. And, and then we talk about set the table. Yeah. Okay, I think this is too much already for me to handle. Okay. So, and obviously there is a sequence of things, isn't it? We can't really do everything in parallel. So we do have a sequence. So we get once we have the milk and the water is boiled, I think we can start making tea, isn't it? So we can make tea only after the water is boiled, which is actually so the third minute we can actually start making tea, and we make it for the few minutes. Let's say 3 more minutes. I'm in the wrong column. Yeah. Okay, toasting bread. When would we toast the bread? After frying the egg, or even before it finishes frying the egg? Maybe after frying the egg. Let's do that, huh?
yeah.
So we, oh, spelling is wrong. Okay. I need to start reading English books a bit more. Maybe toasting bread biscuits 2 minutes, right? Hopefully. And then we start to set the table. And this will probably take a minute. So in real life, you see that even for something as simple as preparing breakfast, we have so many tasks to do. And because we are constrained by time, and then that we want hot food, we usually try to do things in parallel. Like boiling water, we start first thing, as HK pointed out. Then we try to get the milk, and as soon as the water is boiled and milk is there, we start making the tea. And while we are free, we start frying the eggs. And towards the end, because we want hot bread, we will start cooking the bread towards the end. And eventually we set the table and enjoy the breakfast eventually. Yeah. Enjoy the results of our hard work. So that's typically what happens in something as simple as making in the morning. This is just like few minutes in the morning. How much time did we take? Maybe we have 2 minutes to it. So within 10 minutes, we did so much, correct? So this is for any human task, this is how we follow. Similarly, in computer world also, you can imagine that wherever there is a opportunity and a constraint. So opportunity to do things in parallel and constraint of time or throughput, we would like to split it across different CPUs or different CPU cores so that we can accomplish more within the given amount of time. So that is the basic principle behind multithreading, right? So maybe I take another example or prepare a report. Yeah. So let's start with, maybe it's not time in milliseconds. Maybe it's time in milliseconds this time, not minutes or seconds. Let's use seconds. Okay. What do? We want to parse input. Well, input basically means, let's say, a date range. It could be like a report could be like my sales for last 1 month, right? So we will need to pass the input range. We will need to query a database, correct? Let me know if I'm doing something wrong here. Query typically takes a bit of time. Then let's say we have to query a few types of data. So maybe from table, query table. Let me shorten it. Query table of, say, sales table. Yeah. Typically, in a report of sales, what do we need? We need the sale amount and let's say the product. Yeah. And then we can say we want to query product table, let's say, unless we're talking about SQL joins, we can assume this and so on. And then we can say parts data, parts sales data, which you can start only after the query finishes, and we can start parsing product data. And once we have both, or potentially even before that, we can start preparing report data and we say publish. So basically, although this looks very sequential, but there is some parallelism happening. If you might have noticed, there is some parallelism happening in different at the same time. Multiple things are happening, correct? And some tasks are basically cannot be parallelized. Let's call that with a different color. Gray background. Yeah. let's make some tasks which are not parallelizable. Some tasks are parallelizable. So does it look reasonable to you, this kind of report preparation program from your experience?
Yes.
Okay. Rakesh, any input you want to give, or you agree to this?
Yeah, it's fine for me.
Okay. So at different seconds, different things are happening. And about
But
nine,
one question I have here. See, you said preparing report data, right? You said it's not parallel thing, right? But what if multiple? Let's say this is an application where multiple users are logged in, right? So
hmm,
at the back end, like if let's say at a time 10 people are using this app and they are doing out of that 5 people are are trying to access this report data. So it will be a parallel thing, right, for the
yes, you're
application.
absolutely right. So there are many situations where things can happen in parallel, and we want them to happen in parallel. Like the example you just came up with. So yeah, so if there are 10 users and all of them are running, let's say some calculation, some risk number, then you would like to give them all the risk numbers that they're looking for in shortest time possible, because users are very impatient, so they want data fast. Correct? So yeah,
Okay.
that's a even better example. Thanks for sharing that, Rakesh. Yeah. So uh, the point is that we need to do multiple things as a programmer to improve response time, to improve throughput. Um, in some cases, reducing latency might also be, be a part of that equation. By improving throughput, we mean we handle more data in the given amount of time. By improving response time means we obviously take less time to give an answer. By improving latency means we give an answer faster. Yeah. So we talk about response time and throughput for now because that is probably more easy to achieve using parallelism. So in this case, for example, because of our we okay, let's count the number of minutes. So boiling water takes 3, frying eggs takes 4, milk gets 1. So 3 plus 4 plus 1 8 plus 2 makes 10 plus 3 13 and 14. So even before we can do breakfast, we need 14 minutes of effort if we talk that sequentially. But because we are able to do things parallelly, we actually started eating breakfast in the 8th minute. So we actually, it's like almost like 40% improvement in response time because we utilize parallelism. Yeah, this is a very simple way to think about it. Okay. In this example, let's say that do a simple math. So let's say 4. So I'll just try to say here, save how many minutes? 14 minus 8, 6 minutes. Yeah, by doing things in parallel. Right. Right. And let's talk about this guy. So we have 2, 3, 4, 7, 9, 11, 14, 15. 15 actually finished in the 10th second. So here we actually gain 33%. 33% saving in report generation time. So which means we can potentially uh, run more reports because we are now taking less time. Yeah. Cool. So I hope that the parallelism in computing makes sense to you from this example. And obviously, I think it makes sense to you before also, but I thought I'll probably give some example here. So this is what it means. Yeah. So yeah, let me give you a few seconds to digest it and ask any question at the moment. And I hope your Java shell is available. Yeah, please start your Java shells if not. Shall we jump into some coding now? Is everybody okay to continue?
Yes, yes.
Okay. Right. So there are many ways to parallelize things in Java, right? And at the core of it is thread. So, any idea what the thread is? Have you basically thought about it or read about it?
Not really for me.
Okay. How about Rakesh? Do you have any idea what the thread might be?
Yeah, when I was like learning Java by early years, I just remember what do you call the definition. It's like threading is the way where Java you can do multitasking, right? Basically,
Yeah,
it's
that's true. Um, hmm,
though it's not a though it's only I know that only that part like what is coming to my mind like it's kind of a way in which in one of the in which you can do multitasking you can handle multitasking in Java. I think other way is parallelism, but that is something a different concept altogether, I guess.
okay, cool. So, thanks for sharing that. And what I want to talk about is quickly is um, so preparing breakfast. Yeah, is I would like to call it as a process. Okay, so similarly, preparing a report is one process, something that needs to be done, and if we miss some part of it, then we really can't say it is complete. Yeah, so it's like a boundary, you can say. So, so these are basically I'm not including eating the breakfast as part of the process, but that is basically uh, it comes after the process is complete. The process of
That is
breakfast.
kind of an end result of the process, right? It's
Correct.
kind
This
of
is the
an
end result.
output
The
of the,
result
let's
of a
say,
hard work.
yeah, the output of the program. Let's say if we consider it as a program, eating breakfast is kind of a output of the program, the desired output of it.
Yeah. Let me write it here. Good phrase. Cool. So preparing breakfast is a process, and each task inside it is a sequence of things that need to be sequence of steps that need to be done to be able to complete the whole. Yeah. So this is a sequence. This is a sequence. This is a sequence, and so on. So if you yeah, so let's say frying egg had like 4 subtasks, right? Frying egg step one, step four, which would be like heat the pan. There will be break the egg, for example. Yeah, we simplified it, but let's say we heat the pan, break the egg, pour the egg into the pan, and add salt, add salt, etc. Right. So let's say frying egg was one task, but it had a few steps. Agree? This is something that is normal, reasonable.
Yeah.
So this all needs to happen for us to be able to enjoy the fried egg. Correct? So similarly, a thread is something that is responsible for finishing one task. Well, not exactly, but a thread is something that will make sure that all the steps are executed while the whole process is live, or is been so the computer has been told that we need to make a report, so, and the computer will start from the input and end in the output. Yeah. So the computer has called this a process, and inside the process, it has a various tasks to do, and it will use threads to assign tasks to complete each task independently. Okay, so so querying sales data is one series of steps it needs to do. So it will give it one thread. Querying product table is another series of steps that need to be done. It would be like opening a connection to database. It would be then preparing the SQL command and then sending the command to database and waiting for the result. And so there will be multiple steps, right? So all those steps need computing resources, need some action to be taken by the program. And a thread will be something that will be given the responsibility to carry out these steps and these steps only. A thread will be told, this is where you start, this is where you end, and it's just one task. So we typically would then assign different threads. Let's call it main thread here. And then let's say thread 1 will do this job. Thread 2 could be used to do another sequence of steps independently. Thread 3 may be responsible for parsing sales data. Thread 4 may be responsible for parsing product, and thread 5 probably may be responsible for preparing the report, and there could be another thread which could be publishing the report. Yeah. So there are multiple threads available to each program, and it depends on the programmer or the program designer to utilize threads, to create threads and use them or reuse them. So potentially, if thread 1 is used for this task also, and this and this and this and this, then this becomes a sequential program, and it will take 15 minutes, 15 seconds. But because we utilize different threads to do different portions of the overall process, individual tasks, that's why we can use different threads and achieve the time savings that will be one of the objectives of using multiple threads. Okay. So, I mean, I think you'll have to do some reading after the class, get some more sense about threads and processes. So you can, yeah, do have another example in my mind. So like you have an order, like a big order in a factory, then the supervisor, let's say the supervisor is tasked to deliver a particular order. Yeah. So the supervisor will break it down into a series of tasks and assign factory workers with different tasks. And he will also know where the tasks sort of join and become finished product, and whether some task needs another task as an input. So if there is a dependency or not. Yeah. So for example, here there was a dependency between this guy and this guy. Yeah. So let's say boiled water is some color and milk is some color. So these two were needed to make tea. So there are some dependencies also and so on. Anyways, so the point is that we have a bunch of workers and we have an order to finish. So different worker can do different part of the order, and then together, once we combine everything, we get the order complete. Okay, so that's another way to look at thread reverse processing. Okay, so that's basically the theory I wanted to cover. Is there any question that you want to ask about this?
Mm.
Or is it too, what do you say, too complex?
I think it's not too complex, but there would be some method used to manage all the thread, right? I mean, it's like so coordination
Yes,
between.
coordination is there. Yes, that's right. So you need coordination to have some sequencing in where you combine the efforts of different tasks or different threads even. Yeah, you're right. So coordination will come, I guess, once we start making a program which is complicated. So there are very many ways in Java how you can create threads, where you can how you can parallelize subtasks, and how you can combine the results of subtasks to prepare the end result. Yeah, there are obviously many mechanisms in Java to do that. But yeah, good point. So I want to now jump into the practice demo. So there are a few ways I think of creating threads. So I'll touch upon the very basic one, the most simple one also. Are you guys okay with that?
Yeah, sure.
Okay. So we have something called runnable. It's an interface. Let me look, runnable. So there's an interface called runnable, and interface, declares what kind of method it can have. So this guy only has one method called run. Okay. So when we create so let's try to create a class called class myRunnable, which implements runnable interface. Yeah. And what does it implement? How does it implement? By overriding the function void run. So here, what are you going to do? Simple system.out println I am a runnable. We can close the small function, which is void run, and close the creation of my runnable class. Okay, I think I missed something there, which is public class. Yeah, I think that's all. So in JShell, basically like we do in the Java file, this is how you can create a small class inside JShell. All right, and we can then instantiate a variable r equal to new my runnable. Oh, I think we have to declare this guy. Not so intelligent. Okay. So first of all, we have a runnable instance available. Then how do you create a thread? You can do a thread t equal to new thread. This is a Java thread, a Java class called thread, and you have to supply it with some runnable instance. Yeah. So this is how I create a thread. And when I do thread.start, it will tell the computer, the Java virtual machine, that there's a new thread which will be used to execute a task, which is basically inside the run method of my runnable, and please start it as soon as resources are available. This is what it means. Yeah. And because my computer is very free, it basically immediately started the thread and executed the run method, which was doing nothing but printing, hi, I'm a runnable. And as soon as the run method finishes, the thread's job is done. So thread will finish. Okay. So if how do I check? T dot is alive. So there's a method called is alive which says false, which means the thread has finished. Okay. So this is a very basic demonstration of creating a new thread and telling the computer to requesting the computer, in fact, to run the task on that thread, and then checking that the thread has done its job and it is no longer alive. These are the basics of creating your own thread. All right. Can I request you guys to give it a go and maybe just show it to us how you're progressing? Any volunteers? No volunteer today.
Say again, Manu.
Yeah, I wanted a volunteer to actually practice this.
Oh,
And
practice.
yeah,
Yeah, I already typed along the way. So, do we need to do another example?
yeah. So why don't you tell me what other thing you might want to do? Okay, let's try to do two things in parallel this time. Yeah, let's try to another example. Hmm. What should we do? Let's say, if you don't mind, can we switch to a Java file maybe now?
Yep.
All right. So pwd, where am I? Okay, cool. vi thread demo dot java thread demo separate void new string arguments scenario arguments, and then let's create system. I mean, I'm just going to print out that we are going to do a demo here. Welcome to the demo. And then towards the end, I'll just print out system.out.println and then thread demo is now complete. And we'll obviously create our couple of runnables to do the demo. Yeah. So let me create a static class. Static class is a way to create a nested class. Okay. So my runnable, what should I say? My runnable one. And because it, and we need to implement runnable here, implements runnable, and we obviously have to override the run method, and we'll say we'll do something like that. We will say system dot now dot println. What should we say? Well, let's start to say my runnable one has started execution. And let's run a small for loop for I to 0 is less than, let's say, 1 billion I plus plus, and we'll basically just do some addition here. Sum equal to 0, sum plus equal to I, and then finish the for loop. And then we try to add something here which says my runnable thread has completed execution, and then I can say the sum is, and then we can put sum here. We print the sum, and then we'll exit the run method, and then we will finish the static class. Okay, and then we will try to create another static class. My runnable 2 implements runnable also, but this time what should we implement? So the first one we implemented is a printout, and then add some delay by running some and then printing out the output of the delay. In this case, maybe we do something different. What should we do? Maybe we just say we don't do much actually. We just print out that my runnable 2 has started execution, and then we print my runnable 2 has completed execution. Yeah. So we created a runnable class here, and then we close the head demo class. This is the setup. We have one task to do a calculation which could run for some time, and another class runnable which task is to print out the start and stop. It does not do, basically it represents not doing much. Yeah. And then we'll create our two threads. So thread C1 equal to new thread, and here we will say new my runnable 1. We'll give it the instance of the runnable, and then simply we will create the second thread T2, and which will be responsible for running runnable 2, and then we will say T1.start to request the system to run this task, and T2.start. And then what is the correct way to wait for the tasks to complete? There's a method called join. So once we join will basically hang until the thread has completed the run method of its runnable. So we'll just wait for the two threads to finish, and then we will say the demo is complete. Okay, so this is our thread demo with hopefully two threads this time. Is it okay? Any question on this program so far?
Can you repeat again the T1.joy and T2.joy? Is it like joy these two?
No, it is basically the syntax to wait for the thread to finish its job. That's all.
Also, we need to wait for each thread to finish.
Yeah, correct. Otherwise, if we exit the main before the threads have finished their task, means thread may not have completed their task, and we essentially are telling the operating system it's okay to kill them. Yeah. So this basically tells the program, okay, respect the thread, let it finish its job. Yeah?
Okay, got it.
Okay. So let's go to the Session14 folder and compile the thread demo. Okay. All right. So there is a exception that needs to be caught. So I think we should discuss about the exceptions also soon, isn't it? Anyhow, so just add this throws interrupted exception to the main function signature. So that's how it should look. So when you basically have threads or anything that is asynchronous in your program, typically you will see interrupted exception featuring in all those programs. Yeah. So just if you see interrupted exception, which means there's something asynchronous happening in this program. Okay. So compilation is complete. Shall I run the demo now?
Yep.
In fact, before I run the demo, what are you expecting to see in what sequence? Yeah. Let's take a look. So we have, I'll probably copy this over here. So yeah, I want to discuss what are we expecting to see once this. This is the program. So we have a bunch of printouts happening, right? Thread is now complete. So outputs. Let me call it possible output here. So thread demo is complete. There is one called thread demo. Welcome to thread demo. There is my runnable has started execution. My runnable one has completed execution, and the sum is something. We have 6 printouts in this program, correct? So that's what we're going to observe, 6 different printouts. But my question to you now is, what is the order of these that we should see? So I'm guessing the welcome to the thread demo should come first, isn't it?
Yep.
Then perhaps we will see my runnable world has started execution. Then after that, what do you expect to see from the program? Maybe I'll paste it alongside the program.
Um, I think it then next would be my runnable 2 has started.
Okay, so I will promote my runnable 2 has started to display. Okay, fine. Then there are 3 more statements. Which one do you expect to have come first?
Finish task 2. Runnable 1 has completed.
So this is the 4th one, you think? Is correct already?
Yeah.
Okay, and then next one would be?
Yeah, that's the runnable 2 has completed too.
Okay. Rakesh, do you think so? This is okay? Okay, he's agreeing. Right, let's try to run the Java now. Okay, so what do we see? Welcome to thread demo. Runnable 1 has started execution. Runnable 2 has started execution. Runnable 2 has completed. And this is the sum. And so there's one change. So
It takes time to run runnable 1, I guess.
yeah, that's why the runnable 2 finished first. So that's the demo I wanted to give you. So depending on what that each runnable is doing, threads can take time and run in different, basically threads run in different sequences because they help run programs in a different, I mean, different sequence of programs in a different time window or in a different computer CPU, right? That's why they could complete out of sequence. So that is how we prove that the threads are being created and are running independently. The tasks that we given them, and the way to give the task is to create a runnable. Okay. Any question on this demo?
No question, Manu.
Okay, Rakesh, any question from you? Oh, sorry for that, Rakesh. Take care.
No questions. No questions.
Okay, I think that's all I wanted to cover today. Basic thread demo. But I guess you probably please do some reading. Very basic article on threads in Java and practice this program that I have already typed out. And maybe you can try different flavor. You could try to do some different calculations, for example, or different statements that you want to print out, or even more things that you want to do in the thread. Yeah.
If you can put on, add some links like reading links on your GitHub site, that would be
Ah.
useful. Or even in this Excel, it would be fine.
Okay. Yeah. Thanks. I guess I'll do that. Yeah.
So that means each thread can do any of the things we have learned also, like
Pardon me?
rotation, everything.
Uh-huh.
Okay, sure.
Sorry, HK, what is your question on rotation?
Okay, so is it correct that like each thread can do any of the things we have learned, like array, rotation? So all of the things we have learned before, each
You
of it
can,
can be one thread.
yes, you can do, but there is something about data sharing. So different threads, when they share the data without safe mechanism, then there is an issue. Okay. So if you're using the same array to do rotation and printing out in different threads, the result may not be what you expect.
Oh, okay.
So data sharing becomes a bit tedious if you use multiple threads. So I guess what I can say is you can add a volatile variable, make it volatile to make the thread data sharing easy. Okay, so let me do something here. So we have a static integer. Let's make it int my num equal to 100. Yes. Let's say here we change my num equal to 1000. I started execution and I print what my num was. So this becomes slightly complicated already. So we try to print out my num and we then modify the my num to some other value. And this guy is also going to print out my num. Okay. Well, I just try to see what happens in this guy. So if you see the output, the my num equal to 100 is printed out by both the threads. You see,
Yeah.
whereas we had modified it, so but that hasn't taken place. So as I said, basically so there's some safety mechanisms to be done, and one of them is to make the variable volatile. I'm not sure if this is gonna make a difference to the output, because it also depends on the timing. Yeah, it didn't make a difference, unfortunately. Let's do something. But volatile is one keyword that you can use for your array also if you're planning to share array across different threads. Okay, and then you shall not have an issue about safety of data integrity maybe. So yeah, what should I do? Should I do something? Yeah, let's do something similar here also. Yeah, let me set it. Let's add it here towards the end of it. My num equal to my num, and then add a small loop here also in the second one. Maybe not billion, maybe we only run it for a million times. Yeah. Okay, let's see what happens now. Sum equal to 0. So compile this guy. So yeah, HK, can you see the difference? I guess we won't. We can see that the thread while it started, it saw the value as 100, but the time it finished, it saw the value updated. Yeah, because there was a volatile variable there. Now, if I try to remove the volatile, let's see if it makes a difference. Oh, it didn't make a difference. So I guess with, yeah, this is something which is unpredictable, frankly. So did I even, sorry, yeah. So the thing with threads is that it can become unpredictable while you're sharing data. Okay. So we have to use safety mechanisms. One of them, simplest one, is volatile for simple use cases. But there are more complicated use cases, and then we need to use different mechanisms to share data safely. Okay.
Yep.
But let's say, coming back to this example, yeah, if you didn't have to share a lot of data, then it will be probably easy. But because we are sharing data, like water and milk are needed for making tea, so there is some data sharing involved automatically, and hence we need thread safety. Here also, we are sharing data, so we need thread safety. We need to share data safely, basically. That's what I mean by thread safety. Okay.
Yep.
Okay. But at least if you now see a program with the thread running, then I hope you don't get scared about it. That was my objective. That you just, okay, this is thread. It works. It starts like this. It ends like this. Um, that's all actually. Uh, I wanted to do one more thing quickly. I am not sure if I will be allowed to in the given time. Let me do one more thing, final thing before we log off. Okay. I need basically a longer loop so I can show you some more information. Let me try to do some tweaking here. There is a method in thread class called sleep, which can be used to introduce a time delay, but it also needs to throw, it also throws interpret exception. So we need to add it to the run method signature. Sorry, this became more complicated than I was hoping for. Oh, okay, so this is not going to work like that. Okay, so I think if you are okay to do some practice, at least what we did, then next time I can show you more features of safely using a thread. Is that okay?
Yeah, sure. Noted. We will do some reading and do some practice.
Okay. In that case, have a good day, everyone. Have a good weekend. Back.
Thank you, Manu, and everyone. Have a good weekend.
Thank you. Bye-bye.
Bye-bye.